So I think for this one, you can just like just look through the array and then, or look through the string and find the two maximum numbers or the two maximum digits, and just make sure that they're in the first two positions.
Okay. So
for this one, it would be.
But then the answer would be 7,600 and something, right?
Right. So you can only do one operation. So you have to let's see.
I think you have to find the maximum and the minimum and swap those two. And if max and min are same, then we don't swap.
But if the minimum is on the left side, you don't want to do the slash. So you want to find a lesser number on the right and a bigger number on the left.
Yeah.
Only then the swap is profitable.
So yeah, so if let's look at this extreme example, 1, 9. Okay. Do you always swap them? You don't swap them in. Well, in this case, you should swap, right? But if you have 9, 1, then you shouldn't swap.
Like for this question, you have to make sure the largest number is always in the first one, and if it already is, then you make sure the second largest number is in the second position.
Yeah.
Then okay, then you would have to look for the third and make sure that's in the third position.
But you can swap any two numbers or only neighbors.
Any two numbers.
Well, then you just need to bring 9 to the left if you have 9, 8 to the left if you have 8.
Yeah, I think we're definitely on the right track now. So in example 1, so the largest number, the largest digit is 7, right? So basically, in order to maximize our result, 7 needs to be the first digit, right? But the first digit is 2, so we need to swap 2 and 7. Okay. What if 7 is already, if you have something like this, so 7 is already the leftmost digit, right? So now we have to look at the second digit. So the second digit should be the second largest number, right? So the second largest number in this case is 6, but the second digit is not 6. So we want to swap 3 and 6. Okay, so the question is, what if you have multiple candidates, right? So, okay, so let's say that our number is 73626. So we know that the second digit needs to be a 6. So which one do you swap it with? Do you swap the 3 with the first 6 or the second 6?
Well, second, of course.
Second, of course, because you want to, in order to maximize the result, we want the 3 to be as right as possible, right? So is it always the case? Like if we see, if we need to swap the current digit with something bigger than it, then we always swap it with the rightmost such digit. So how about this? So, okay. All right, so in this case, we know that the first digit needs to be a 6 because 6 is the largest digit here, right? So we need to swap 1 with one of the 6s. Now, which one do we swap it with?
Last one.
Yeah,
the last one, right? So our answer should be this. Okay. So I think that's it, right? So how are we going to implement this one? What data structure do we plan to use to quickly know which one to swap it with? So first you need to know that the first digit is the biggest number and the second digit is the second biggest number. So how do we do that? How do we know the expected digit? Well, we can just sort it.
Yes. Okay.
Right, we can just sort the digits, right, from large to small. So then we compare the current digit with the first digit with the largest one, then the second digit with the second largest one, the third digit with the third largest one, etc. Right, but also we need to figure out the index to swap. So if you realize that, oh, the first digit is the largest number, but the second digit is not the second largest number, so I know that I need to swap the second index with the last occurrence of the second largest number, right? In this case, it's 6. So
I say we just traverse this number from right to left in the search of our largest number. I mean, it's going to be big
sure.
O of n, but we're already in big O of n because we're scanning this number from left to right. Plus, we're doing sorting.
Yeah.
Technically and log n, technically.
Yeah. Okay. That makes sense. Does anyone want to implement this one? Alex, do you want to implement this one?
Yeah, one sec. All right. I already forgot what the algorithm was. Yeah, let's see. So we have the string, right? Let's say this is a string. Then, yeah, let's say it's this. Then what do? We sort it, right? We sort it. Then we go through the first string and we make sure that it has to be equal to this guy. And if it's not equal to this guy, then we just find this guy anywhere in the original string into this form, right? I think that's it.
String dot value of, right?
Yeah.
I don't think it's integer dot value, string dot value.
I think it's just two string.
Okay.
All right. Yeah. $1 million question. How do we sort array in Java? Who knows Java? Okay. Will this compile? Okay, this will compile. It just sorts array in the reverse order.
Yeah.
That's not. This is not what I need.
It's not necessary that you sort it in the reverse order. You can sort it from small to large. You just need to view it from right to left, right?
Yeah, I know. I'm just too lazy to
keep track of like two indices. I see.
Let's try this.
Yeah.
Total bust. Okay. Why? Yeah. Now this. Well, the thing is, this is sorted as I need it. Right?
Okay, so the sorting is correct.
Sorting is correct. And this should also be
Okay. Okay, can we print the INJ that you're swapping? Can we just print the INJ?
Yeah, just one sec. Yeah, I screwed up this swap. That's what happened.
Okay, so the problem is you're swapping twice.
Yeah. All right.
How about just after swapping, just return the result so that you don't need this boolean?
Okay. Oh, I did
I-
it before. As
Okay.
always.
So actually on line 20, you know, if you can ever get to line 20, that means you're returning the original result, original
Yeah.
input, right? Yeah.
And it's slower,
Yeah.
of course.
Okay.
How did I do it in the past? I think it was simpler. Oh wait, no, it was much worse.
Okay. Now if the interviewer says, okay, you cannot do two passes, right? So here you're doing two passes. One pass you're sorting it, and then you know you have this for loop on line 9, which is going from right to left to figure out the last occurrence of this number, this digit, right? How do you find the last occurrence without doing another traversal?
I don't know. I was thinking about having a tree map of yeah, the tree map where key is the value.
And the value is
and the value is index. Right.
Okay.
No,
Okay.
and value is the priority. Well, the list of indexes, right?
List of indexes. So
Yeah.
so basically the key is like 6, and the value is the occurrences of 6, right? The indices where 6 occurred. So
Yeah.
okay, so is there any value
number.
in storing all occurrences of 6? We only
Well,
care about the rightmost one, right?
Oh yeah, actually, yeah. You can just have a hash map, and that's it.
Yeah, just have a hash map where the key is the digit and the value is just the rightmost index.
Yeah, the latest index
of that digit.
You know what? Let's do it now.
Okay.
Right. What? Ah. And it's even slower, of course, as always.
Okay.
Yeah.
This is good. Any questions, anyone? No questions? Okay. Okay, good job, Alex.